All right, I see a lot of familiar faces out there. My name is Sam Taggart. Most of you guys know me. If not, you can read a little bit about me there. For our giants are female. I happened to go to, when I was in London, I went to Greenwich, and I went to the Maritime Museum, and they had a really cool exhibit on the moon and the lunar landing. So if you want to go check that out, I think it was 10 pounds. But I happened to see this thing here, and I thought, wow, OK, this will work out well for our giants are female. And apparently, Margaret Hamilton led a team at MIT, and she wrote a bunch of the software for the Apollo mission. And apparently, it's punch cards, because that's a heck of a lot of stuff. But anyway, I thought that was interesting. I thought I would include that. I saw on the first slide that there are a bunch of us from North America. If you're from North America and you're interested in seeing some sort of GDevCon type thing, come to Denver, or I live in Denver, so I was planning on having it in Denver, but anywhere in North America, come let me know, and we've got a little committee forming to kind of look into that. So, and as you know, I'm sure part of the reason you're all here is that some of the NI events have been disappearing, and so we lost our CLD summit in Denver, and so they decided they wanted to replace that, and I kind of had a bigger vision, so maybe we can make it work. All right, so Nancy put me onto this book called xUnit Test Patterns, and that kind of forms the basis of this presentation. I didn't bring it because it literally weighs a ton. It's like 900 pages, and it's thicker than any college textbook I've ever seen. Nancy didn't tell me that. I ordered it on Amazon. I got this huge box. I couldn't even lift it off the table. I was like, what the heck's in here? So I don't recommend reading that book. Fabiola has a book. I mean, it's got good information in it, but it's 900 pages. There's a book by Ray Osherov. Yes, I have it sitting on my table. I haven't read it yet, but Fabiola assures me it's good, and I trust Fab. And it's only this thick, so yeah. And it gets lots of good reviews elsewhere. But if you're bored and you have trouble sleeping, this is a good reference. All right. So this little tidbit I picked up from Steve Watt's book. And basically, there are two things we need to know, right, before we start any project. Right? And Steve was talking in terms of project management, but I think it applies here as well. The first thing you need to know is, where are we going? Right? What's our goal? What are we trying to accomplish? Right? And you also kind of need to know, what are the business goals? What's the business hope to get out of this, right? Because we all do. None of us program for free, right? So we all work for a business, and they're trying to make money. And so we got to figure out how to connect all that. And in Steve's book, he mentions, having a project plan and some requirements and that type of stuff. And then, how do we know when we finally get there, right? So in the UK, apparently, you guys do way more fixed price projects, and that's what Steve does. And so he wants to have a nice way to be able to tell the customer, hey, look, we did what we said we were going to do. Pay me now, right? So that's important, right? So one of the things he recommends is having a test plan, right? So my presentation is on test-driven development, right? So if we take a look at unit testing can give us both of those things. It can help us to define where we're going and what we're trying to do. If we write the test first, the tests act as a specification. They specify what's supposed to happen. And then that specification, it's not just written on a piece of paper, it's actual code, so we can run it. And we can verify that, in this case, we're not where we said we were going to go. But when we get to the done, we can run all our tests and say, yes, we are right where we want to be. Right? So unit testing and test-driven development are very much like a project plan. Right? The tests are the project plan, and they're also the test at the end that tells you when you're done. You guys can shout out and ask questions, by the way, as we go. I value the comments and stuff more so than the presentation sometimes. So, all right, test-driven development. We had some discussion yesterday about test-driven development versus design. I'm talking about test-driven development, but it does require some test-driven design as well, right? So the one key statement, there's whole kinds of debates and discussions and raging stuff online about this. The main thing is write the test first, then write your production code, okay? And I think it actually makes a difference to actually write the test first. When we were talking about test-driven design, it's, oh, think about the tests, and okay, and that's a start. You do need to think about that. But when you write the test for it, it actually forces you to write testable code, and you know your code is testable. It's not like, well, I think that if I do this, it'll be testable. It's like, no, either it is or it isn't. And you do it iteratively. So, you know, you're adding a feature, and you define part of that feature, and you write a unit test, and it fails, and then you go back and forth. And we'll talk about that in the next slide. But I have a picture of a brain up here because it's really a mental shift. It's changing the way you think about the problem. And if you've never done it, it's hard to imagine, but trust me, it's kind of like learning object-oriented programming, right? It like doesn't make sense, you don't quite get it, you start going, and all of a sudden you hit this like aha moment, and you get it. Once you get this, you won't go back. It's like, how many people have learned object-oriented programming, right? How many people would go back and not use objects? Right? I know Steve's not the biggest fan, you know, thinks they're overrated sometimes, but you know, I started using objects, I'm not going back. Right? If you start doing this, you're not going to go back either. So yeah, you write the test so that you can write the production code. You don't write the test to test your code. Because when you write the test after the fact, A, it's always harder to write the test because you didn't write it to be testable. Right? So, all right. So this is basically what the process looks like. You start here, you decide you're going to create a new feature. You write a test or tests to test your new feature. You verify that that particular test fails, right? Because you want to make sure you're not getting false positives. Right? So you run the test, you see it's red, you're like, OK. And then you write or edit your code. And you check to see that all tests pass, not just the one you wrote. You run the entire unit test suite to make sure that you don't jack up anything else anywhere, right? No unintended consequences. If they don't pass, you go back, you edit your code some more, and you keep going around and around until you're done. And then you go back and say, OK, is there another feature I can add, or what am I doing next? Right? All right, let's see. All right, but not so fast. You say, you want me to write my test first? Well, that's great, but what do I drop in my test? All right? For those of you who don't recognize, this is something I picked up from James McNally and also from that big book. I think James did it in 3 frames. The book uses 4. Right? So we got a setup stage, exercise stage, which is what we're testing, verify stage, and then at the end you do a teardown. Right? And this is using JKI VI tester. You can use whatever you want. The principle's the same. And you'll get a look at this later, and I'll explain exactly what this test does. But yes?
Just to plug James McNally toolkit, VTAG. It's available now on the Labitus network, and it has a template. It is given then when, but
yep.
The template is on the palette. So.
Cool. Yeah, I just made my own template and put it in. The template's pretty easy, but yeah. But it is cool that it's on the tools network. I know how much of a pain that is, so congratulations. In fact, I don't know, I'm thinking that what I'm going to show you guys in a minute, I will put on the tools network, only because it's really small and it doesn't have a lot of, they can't make me jump through that many hoops for like a handful of VIs, I hope. Yes?
What was the tool that Fabiola was mentioning?
VITAC, V-I-T-A-C. It's VI Tester Analysis and Comparisons or something. Advanced Comparisons.
And then I added templates after I named it.
OK, and templates. So yeah, it's really useful. The basic JKI VI tester stuff just does like equals, and his will like give you more information. JKI VI tester sometimes just tells you these 2 things aren't equal, and you're like, OK, well, why not? If they're like arrays or clusters, it's not super useful. So James's stuff makes it more useful. All right, so all this theory stuff is great, and reading books is great, but it really comes down to how do you actually use it and apply it in the real world, right? Knowledge doesn't do anything if you don't do anything with it. So this is an example project that I put together. It's actually open source. You can go there and get it. If somebody wants to take a picture, I'll wait a second or 2. If not, you'll see this again later. I encourage you to go take a look at it. If I was really smart, I would have like checked in after I did every test in my iteration, but I did not. So mostly because some of them are really simple, so you don't get to step through every test, but you'll see the basics of the idea. All right, so this is the problem I started out trying to solve. How many people use tdms files? I know James Mack does because he did a presentation on it in an iWeek. Doing the header stuff is a pain in the butt, right? You've got cluster full of properties for your channel or your test or whatever. And if you want to write them, you got to break it out and unbundle each one and put the names there, and it's a pain. If you want to expand that, right, it'd be really nice if you could just drop something into your cluster, right? And same here for reading them, right? So how many people think that's a pain? Anybody done that? It's a cool pain, right? Hopefully, I see a few hands. So I thought, well, somebody's already solved this problem. I picked the MGI ones, but JKI, or not JKI, OpenG has one as well. The read-write anything INI file stuff where you pass in a variant, and it uses the names of the elements of the variant to define the things, and the data types define the data types. And so I thought, well, I can do that with tdms files. And I just read this book, and I thought, well, this would be a good project to try some test-driven development, because I'd like to test this if I'm going to do it, you know? I want to make sure that everything's working correctly. So I thought that would be a good project. And so, you know, back to my thing, I wanted to do the tests. I started to write the tests, and I realized I need an API first. So I came up with an API. And I also decided to be brave and try out some Vims, because I thought that was pretty cool, because it gets rid of the data or variant to data thing here, right? You just move it inside the Vim, and everybody's happy. And I also decided that I would use that for the path or ref. So you can pass in a path, and it'll open and close the file, or you pass in a ref, and it'll just keep the ref open. So I thought that was kind of handy and useful. And that's pretty much the API for my little thing. I've got a write to header that takes a cluster, and a read from header. You give it a cluster, and it pulls out all the data. And it also gives you some other information that I think is useful, like were any keys missing, and which ones were missing, if anything was missing. So, any questions so far? At least the API is pretty straightforward. The code, not quite as much, but. So I started writing my code now. And you know, I know I said write the test first, but I had to write a little bit of code to get the Vim stuff to work right, so that when I dropped it on the block diagram, everything coerced right. So you'll notice all I really have are some type specialization structures and one or two little primitives. That just makes the Vim work, so when I drop it in my test, everything coerces right. That's not actual real code. I probably could have got away with a little bit less than what I put there. Could have got rid of a few of them, but that's basically it. So it doesn't do anything yet. And so from the book, right, when you're writing tests, you can't test everything, right? It's impossible to enumerate all the possible inputs, especially when you get into like inputs like strings or doubles, right? You're going to get flipped through every bit. Like, that's kind of ridiculous. So you got to prioritize. And so it recommends, and I recommend, the first thing you do is do your happy path, which is if everything goes 100% well, and this is used the way it's supposed to be used, this is what should happen. Right? And then I have what I call, so that's like the 90% case. The unhappy path is like the 10% case where like, okay, yeah, it should handle this situation gracefully. And then you have a few corner cases maybe that you want to try. And last, kind of the error paths. Don't ignore the error paths, but kind of push them down, and you can catch those at the end. Is my general philosophy. Well, unhappy path is like something that you anticipate happening, but it's not like the main way it's supposed to be used. Corner case is just like making sure that like somebody passes in 0 and you're doing a divide, that you come up with something intelligible, I guess. I don't know. Honestly, this is just a rule of thumb. You don't have to follow it exactly. It's just some way of prioritizing, like, okay, what are all my test cases going to be, right? Because you got to come up with some test cases, and so that's what I chose. You can choose whatever you'd like. There's really no semantics to any of those. I didn't pick those words for any reason other than that's kind of what was in the book. All right, so I wrote the test for my happy path first. And so in my setup, I'm just creating a temporary tdms file. I am writing a cluster of data to it. I'm reading back that same cluster and checking to see that they're equal, right? So if I store a cluster of data in the file and I pull it back out, they should be equal. And here in the teardown, I'm just deleting my temporary file. And this cluster, I took a cluster and I dropped in it every type of data that's allowable in the tdms header, right? So there's I32s, all that. And then this sub-VI just takes that and puts some values in it that are not the default values to make sure that like when you read it and write back, it's not just taking those values and passing them out. And that's my test. That was my first test. Now, some of you unit test guys, you say, well, that's a pretty poor unit test, and it is, right? It's a great smoke test to say that something's wrong. It doesn't really help me with defect localization, right? Because if something doesn't work right, was it the data type that I used? Was it the reading? Was it the writing, right? But I had to start somewhere, so I picked that and made that my starting point. And I figured, if that works, okay, at least I'm on the right track and I'm getting somewhere. And so, of course, I ran it, and it failed because my code didn't do anything. And it didn't take very long to fail. And then I wrote some code to fill that in. And this is the code for the, which one is this? This is the right. So I basically just dropped the sub-VI in here. And this is what's inside the sub-VI. I took my variant, converted to an array of variants, pulled off the name, and used that in the tdms file property thing, like the variant, and was able to pull off the type itself, and everything worked. And for reading, I basically just did the same thing. Here I had to do some fanciness, some bit flipping or something to get it in order so that I could get it back to a variant that would then go into the variant to data and get it back out to what I wanted. And you'll notice over here, so here this is the sub-VI that's over here. But here I didn't wire up the missing keys things at all yet, right? So one of the things of TDD is when you write the test first, and you write just enough code to get the test that you wrote to pass. And that way you avoid writing all this superfluous stuff and adding in all this flexibility that you don't really need, right? So my test doesn't test those things yet. I will get to testing those, but I'm not worried about them for the moment. And of course, I ran that and my test passed. Perfect. Right, I'm on my way. I've got something that works, right? Doesn't do everything I need it to do, but at least that one feature, if I write a cluster and read it, comes back. Okay. And then I added a whole bunch of tests for all the other things. I should say a word about test naming. I picked up this convention from the book. You probably can't read all that, but for VI tester, everything has to start with test. And then I try to name the VI that I'm testing. And then I listed whether it was a file, channel, or group property, because I wrote one for each, because the tdms things work at 3 levels. And then I wrote whatever the input was, and then I had returns, whatever was supposed to come back. And I broke them out. So like this one in particular, right, this one is checking. So if I create a tdms file, and I have a group, and I have a channel, those are just generic group and channel names. This is like a test helper VI that basically just takes that file and adds that group and channel to it. So the group and channel exist. And then here is a non-existent key. And if I try to read a non-existent key, it should come up, missing key should be true. Now, it should also output the name of the missing key, but I have a separate test for that. So I separated those tests so that then when I have problems, I know exactly which thing's not working. Right? Is it that it didn't show up in the list, or is it it didn't detect it, that it was missing at all? And here I clean up, and that's pretty much my tests. And all of them are basically like this. Now, there's probably, maybe 20 tests in there, 30 tests, I don't know, I didn't count them. You might think that's a lot of work. It's really not, because 99% of them are copy and paste. You do one, you copy it, you paste it, you change the expected inputs and outputs, and that's it. And it's really simple. So don't be daunted by the amount of work there. It's really not that bad. The real work actually is in the thought process of what am I going to test and how am I going to design my code so it's testable. But that's totally a worthwhile investment. You should be doing that anyway.
Yeah, but that's the initial step when you design the tests. Once you start fixing. Okay, this is the initial step. You design the test. Once your library is done, and you want to add features or fix bugs, which would be there probably.
There are no bugs because I just tested it all.
Oh, that's unit
Very
test.
few bugs.
No,
I'm just joking.
no.
Yeah, but
So
yeah.
I'm getting back to my point. You need to consider how much time it will take to sync up your unit tests to changes in the library, in the API implementation.
Yes, that is a valid point. If you're going to change your API, you do have to change your unit test. That is true.
And implementation too.
So if I'm going to,
More time that you
well,
found out.
no, well, if you're going to fix a bug, okay, A, you're going to have to edit your code, right? How do you know, A, that you didn't break everything else, and how do you know that you actually fixed what was broken, right? So if you want to know you fixed what was broken, you should write a unit test, right? So you write a unit test, right? You run it to verify that the bug is there and that it catches it. Then you fix it, then you run the unit test, and then you verify that you didn't break anything else. So for bugs, that's fine. You want to add a feature, same thing, right? You add a new unit test for your new feature. You implement it. If you break stuff, you go back and fix it. And if your tests don't run because you changed something in the API, then you have to go back and fix your tests. So yes, that does happen. But that also alerts you that you've made a broken change in your API, so then when you distribute it, you let people know. You say, hey, look, I changed this. You know, this is a new major rev, and this is what changed. So I guess I'm not seeing the downside. I mean, yes, it's a little bit of extra work, but you get a ton of benefit out of it.
Yes, it is extra work, and one other thing I want to point out that unit tests are fragile. They really tend to break when you start changing features.
Well, that's the idea.
And you need to take care of them because otherwise, after some fixes or adding new features, they are broken forever. You will just abandon them. You need to maintain them synchronously with changes to your implementation.
Let me answer that, and then I'll let Fab go. If you're having problems with your unit tests breaking constantly, you should go back and read that big, thick book, because that is what that book was written to address. That book is all about how to write unit tests that are maintainable so that as your code base grows and you make changes, there are tons of patterns and design ideas and stuff in there to help you cope with that. I'm not going to go into them here because there's 900 pages of them, but if you're having that issue, it is probably worth your time to read that book. If you're not having that issue, stay away from that book. Go use the book that Fab recommends.
So I think what happens is that when people start using unit tests, they get very excited about it, maybe use them, and then they stop using them. If you are really using them, it becomes part of your workflow. So you pull from the repository, you update, you run your unit tests. Even if nothing changed in the repository, you verify that they still pass. Then you go and do everything he said. So because it becomes part of your workflow, and before you commit, you run your unit test, you make sure it passes, and then you push. Because it becomes part of your workflow, it's a lot harder for them to become stale. But yes, you're right. They're like documentation. If you don't keep up to them, they're going to be lying to you.
Yes, but if they lie, you run the thing and you know. One other thing that comes up with what Fab said is you want your unit tests to be fast, right? Because if it's part of your workflow, you don't want to be waiting 5 minutes every time. So if you have issues with speed, that 900-page book also has some hints and tips and tricks for that as well. So if you're not having issues, just read Fab's book. And then when you run into issues, go consult the 900-page reference manual. OK, so that's pretty much my whole TDD experience, right? So I mean, these are all the tests I added, and I would add a couple, and then refactor and change and add some stuff, and then add a couple more and do all that. And I got to that point where I was done. Now, test-driven design, right, doesn't exist in a vacuum, right? It's part of your whole process. And so this is originally, I was going to do this whole continuous integration thing with this, just because I wanted to play around with it and see how it worked and just kind of try a few things. And so my original thought, this is where I start out, I would have like, these would be stages, right, in my pipeline. And so I was going to, every time I check in on every branch, run VI Analyzer and run my unit test suite. And then have, when I committed on my master, right, so this was before I had started doing the whole Git flow thing, right? I was doing like a GitLab flow or some other thing. So I was actually doing builds off my master. And when I checked into that, I would create a VIP file and build that and do a test install. And then the test install would basically run on a fresh machine, take the VIP file that I created, and run some customer tests using JKI tester. So there's a new scripting method in LabVIEW 2019 that will let you replace stuff in the project. So you can take my LVlib, and I can build a PPL and replace the LVlib with the PPL in my tests. programmatically and then run my tests against the PPL, which is really nice. So I verified that the same tests that I ran against the lblib run against the PPL, and then I know that it's good. And then I was going to, and then if I tagged a release or something, I would deploy it to Nextcloud and send myself an email telling me where to go get it. This was my plan. I didn't actually do all of this stuff because I realized that for this tiny little project, it was kind of overkill, and I ran out of time. So I may still do some of this stuff. I would like to put this toolkit on the tools network, and if I do, and I have to jump through a bunch of hoops, I'll probably do this. Right. One thing I did do that's kind of not traditional continuous integration in the sense that it's not all happening on this build server or whatever, but I did do a pre-build VI with VIPM to just run my test before I build, and if it fails, I throw up a dialog box and output an error. Dialog box is probably superfluous, but. And once I installed it, I made this nice little palette, and so you can open a tdms file, set some properties, write some clusters, and read them, and close it. And again, there is the path to the GitLab repository, so you can go check it out. All right, so some of the benefits that I've seen from this, and Fab can probably talk a lot about some other ones. If I miss some, let me know. Maybe you can talk about some that you've seen, but better API design. Definitely having the unit test really made me think out the API and test things out. And especially with the VIMs, I thought the unit tests were really nice because I got to see how it actually reacted when I wired different things up to it. And, if you've played with VIMs, that can be tricky trying to sort all that out. My code is definitely testable, right? I feel like I wrote cleaner code because I was trying to do just enough to pass the test and not really writing all this superfluous stuff and doing all this extra error checking and things. I did catch a couple bugs, a couple things that I missed when I was doing the missing keys. I thought I had it all figured out, and then I ran it, and I missed a special case. So I don't know if I would have caught that if I hadn't written the unit tests. I don't know that it necessarily matters that I wrote them first, but without the unit tests, I'm pretty sure I would have missed it. And then it just really gave me a lot of clarity about what I was doing and what my goal was and what I was trying to accomplish. Questions? Yes. I've got a microphone.
This may be more a comment, but I found it's also really useful to have somebody write the unit tests that isn't the one writing the code, because then they can catch more things that the person writing it didn't think to check for.
I think that's really awesome. You're going to come work for me and write unit tests. Because it's kind of hard for me to write my own unit tests. Anybody else wants to do that, let me know. Yes, Odd.
Yeah, do you try any GUI testing?
GUI testing.
It doesn't really maybe fit the scope.
Yeah, no, for this. Yeah, so for this, it does not fit this scope. But one thing I've been thinking is, so I'm reading this Python book, and it talks about using something called Selenium, which works in a web browser to do like GUI-based testing. And if you combine that with like web VIs or something, then I think that would be a really cool way to do some GUI testing and automate it. But I haven't gone down that road yet. I don't know a whole lot about it. But I do think that's cool, because it's really easy to use JKI VI tester to test like the underlaying stuff, but to test the actual GUI, it's really hard. But if it was a web VI, and web developers, I'm sure, know how to do all that. I don't know if anybody else in here does web development, but they probably tell us a lot about it.
There is a suite from HP which can test the GUI in .NET or any other platform.
OK, very cool.
OK,
we have a question over here first.
The whole unit testing thing, I'm pretty new to it, but I'm all about my state stuff. So my first impression is when I read later that, yes, it can handle stateful VIs, but whenever it is presented, it always assumes that that piece of code that you are testing is purely transformational. So it has inputs and outputs and nothing else. And the reaction of and the outputs depend on inputs only, not on the internal state of that same piece of code that can be different at different moments of time.
OK, so let me address that. So the whole statefulness thing, yeah, you got to have some way to put it in the correct state. But to your point, though, there is hard to test code. And that book, the 900-page book, talks about it, and I'm sure the Osherov book does too. So sometimes where you're like, so there's like direct inputs and outputs, right? So there's things that are on the connector pane that you can wire stuff to and you can read from. Those are easy, right? It's easy to drop in a test harness and do that. What gets harder is when the thing writes to a serial port, right? Or writes something over the network or whatever, right? Because it depends on external resources that may or may not be there and that you may or may not have control over or have visibility into.
Where you don't know when
Yeah.
push the button and which button is being pushed.
Yes, exactly. So the 900-page book, and I'm sure the Ostrov book too, talks a lot about how you build. So this is like test-driven development. It kind of leads to test-driven design and how you design your software. And on my blog, I wrote a whole series of posts on humble objects and test doubles and all that. And you should go check those out. They're really good articles. Yes?
Very much to that.
I have a similar presentation that I'm putting together that's more actor-focused. And it can be hard to look into an actor because they are stateful, and the answer to that is very often how you design the actor. You know, can I have, you know, an object that maintains state? And since I have an object that maintains state, I can set it up with in my test setup with whatever parameters I want it to have initially. And that object being buried in an actor, it's safe. Nobody can get to it, you know, during execution. But then I can you know, influence my object, and then I can pull that component out and inspect it as a part of that test.
How exactly do you do in the code frameworks like this, which kind of assume you have inputs and outputs? You have to run that VI and you can vary inputs and you're just supposed to check the output.
Well, I mean, if you're carrying around state, if you're carrying around your state as a parameter, you can inspect that parameter. It's just another output.
You have to have means to force your code into certain.
Yes, it changes the design of your code.
From outside of itself.
Yes.
It
So
changes the design of your code.
There are techniques to do that.
Designed to specifically not to allow that in the program.
Okay.
No, let Fab talk. I think
Yeah,
Fab's
so-
got, and James also is a
Yeah,
guru
so
at this, let
there's
him
two
talk
things
too
there.
in a second.
When I get hired to rescue code that needs to be maintained for FDA or regulation or whatever, so they want me to add the unit tests after the fact. They were not created. I get that pushback a lot. It's like you're asking me to redesign my code in order to make it testable. And thankful for me, most of these companies I work with have hardware. And I asked them, if you create a PCB board and you're sending it for manufacturing test and you forgot to add a test point, do you wrap the board? And the question is yes, right? Because you need to add the test point in order to test the thing that's important for your system. So it's the same thing. You need to wrap your code in order to make it testable. It doesn't have to be with adding inputs and outputs. There are clever ways, like using events or other ways. And McNally has a really good post on how to test LabVIEW FPGA code. Because that's, the LabVIEW FPGA code is a good example too, because it's hardware and it needs multiple iterations. And what he does is basically using the pipelining that you can do, chip registers, in order to exercise your code through the different states you want. So you get it to a point where it is okay for your code to be inspected. But the main thing is you need to wrap it to add a test point.
Should allow being forced into
Yeah.
all these things to be tested.
But, so I think, James, do you have something to add first or no? For you guys?
Yeah, I think Fab summarized most of what I was going to say anyway. But I'd also say, you know, there's other philosophical debates around this, and this will put me down. Is you're testing the API? That's what you're testing. You're not testing. You are exercising the internals, but generally you want to be calling the public API, and that's one of the ways you avoid tests being too brittle. And so you must have public API steps to get your code into that state. So that's where your setup and your teardown comes in. You use your setup and teardown to go, right, I need to initialize this into a certain state. You don't have to take any shortcuts because it can be done through the public API. If it can't be done through the public API, then it can never happen anyway and there's no need to test it.
I think, well, Michael first, sorry.
Yeah, because here we are also talking about the design from the beginning. And those are two separate topics, whether we need to rescue some code and put it into the test harness and allow to go to make it through regulatory statements, And it's completely different from what we designed from the beginning. We design code to be testable, and we allow those special test points to be there from the very beginning.
And we get better code.
Yes.
That's the thing. The code itself is improved. This is what I'm finding. I finally got a project where I could get somebody to pay me to do this, so I'm getting a really deep dive for the last year and a half on this. And what I am finding is, by virtue of having to write code that I can test, and it's all actor-based, so I send it a message and I see what message it sends out, right? It's kind of a black box. Or I send it a message and I stop the actor and I inspect the actor. And what I'm finding by doing this is the code is structurally more sound and more flexible because I am building for these things.
Less coupling.
For that type of code, do you need then messages that it should accept only during testing?
No.
No.
I only test the actual messages that get sent. If the actor is a black box, I give it a stimulus, I expect a response, end of story. There are a few cases where I stop the actor and then I get the actor back as part of it, and I can inspect attributes. And so I'll have, the most I'll have for test points is I will have some extra read accessors, or maybe some extra write accessors to set the thing up to begin with. And that's the only thing that some people might think is a little naughty. I'm unlucky with actors because the accessors get buried once the actor's running.
So you still have methods that are designed specifically for testing that code. If your code has code for that code to be tested, for the main part of the module code to be tested, you have additional code inside that code.
But they're just accessors.
Well, anyways, so you do. So, but you're saying you're not using, say, special messages to put your actor into this particular state just to be able to test how it will react.
As James was saying, if I have to set an actor up in a particular way, I may have to send it 3 or 4 messages to get it where I expect it to be. But there's actually some interesting feedback on actor design, because should the actor actually be that way? But that's a whole separate discussion. Yes, there are a few cases where I need to send a message or two to prime the actor prior to sending the message of interest.
That may not be possible without, say, programmatic simulation, full-blown simulation of particular, say, input values that it deals with.
Yes. So, I'll let James talk and then we'll wrap this discussion up, because I kind of want to hit a few more points.
Well, I think you might be talking about this anyway, but yeah, I/O is a challenge. So if you go to other languages, they just don't test it. Anything like that. There are some techniques which you touched on which can help with that. I generally, depend if it's file I/O, I'll test it. If it's hardware I/O, you can't test it. And so you want to make the hardware I/O layer really thin, so there's lower chance of bugs. And then any processing or manipulation on top, you then do that separately so you can test that. And that's where the test feeds back into the design of the code in order to do it. But there's a level of pragmatism with all of this. I think it's not a golden bullet. It's not going to tell you always exactly where the problem is. And there's a point at which you have to be pragmatic over what's worth trying to test. Okay, maybe ideally you wouldn't add those methods, but you need to test it, and it's more useful to have it tested than the cost of putting those in.
And not risky, it doesn't create a risk.
Yep.
Yeah, and it's not implementing risk. So, it's one of those topics where there's a lot of, this is the right way to do it. The more I've done it, the more those have slipped away, and I've gone, this is the pragmatic.
Yeah.
Yeah.
And you never test 100% of your code.
It just doesn't work, and it's not practical. Okay, so if you're interested in learning more about those type of techniques, there are some techniques. I mentioned a couple. There's some on my blog posts, and if anybody's going to the CLA Summit in a month or two, I'm giving a presentation on mock objects then too, which is another solution that will help you do some of that. This is my last slide, so I do like all the comments and talking. I just thought we beat that horse already. Some lessons that I've learned. It is an investment, right? But like a good investment, it pays interest and dividends, right? So you invest a little bit of time up front, but you get paid back later, and it's totally worth it. Go slow to go fast. So it will feel like, in the beginning, that you're slowing down, right? Because now, I've got to make a new change. Okay, I check it out. I got to run my tests. I got to go write a new test, and then I start coding. But you go way faster because you spend no time debugging pretty much. You write your test, and if you don't spend time chasing down. If you break something else, the tests tell you immediately, and you know right where to look and things like that. So you're not hunting bugs. You still got to fix them, but you don't have to hunt them down. Copying tests makes for really quick test writing. You'll notice you got your VI. It's got the same sets of inputs and outputs. You're just copy it, change the inputs, change the matching outputs, and you're done. Maybe edit a comment. So you can create a whole bunch of tests really quickly. Debugging tests sucks. So you want to make your test logic as simple as you can. Don't put a bunch of conditionals in there. All right. Is this one on? Hey, all right. Yeah, debugging tests sucks, and CI is really nice, but it doesn't always add value. In this case, the project's kind of small. I built it once, and unless I find a bug, I'm probably not going to build it again. So adding CI to it just didn't really seem to make a lot of sense. But if I go through the whole tools network thing, I'm sure they'll make me change some stuff and jump through some hoops, and maybe it'll be worth adding that. All right, we still have 5 minutes, so I don't know who's in charge. If you want us to just break early, or we can ask more questions, we can beat another dead horse or something. Oh, okay. Here.
What proportion of your time, sorry, you know this is going, don't you? What proportion of time do you think you spend writing tests compared to writing code? That's quite a simple VI you wrote with 30 tests associated. In a bigger application, that is a lot of tests to write.
Well, I think part of it goes to what Fabiola said, that you don't necessarily have to test everything, right? Some tests are better than no tests, right? So you should write some. Whether you test everything or not, that kind of depends. Add the tests where they give you value, right? So for example, this is a reusable library that I'm probably going to use in a lot of projects, so it makes a lot of sense to spend some time testing it, right? Or if you had some critical section of code in your project that had to always work, that's worth testing. Some like logging code, maybe you don't care. If the debugging log, who cares if that screws up or doesn't do something correctly, maybe. I don't know.
So one thing we said at the workshop yesterday is the issue with this is you won't really appreciate unit tests until you actually work on a code that already has the unit tests. So you're going to have to kind of believe us and then start trying it in a project. And when you get to that point where you are changing things and you already have the battery of tests, that's when you're going to be like, okay, now I see it. So yeah, unfortunately, you have to manufacture the experience in order to see it. The one suggestion to get started is next time you have a bug, create the unit test first. That will convince you that you have fixed the bug, and then go fix the bug.
Something I found that works really well is, so you start by designing your API. Then you write the documentation of your VI. So you say basically, okay, this VI is supposed to do that, and if you do that, it's going to throw an error, and if you do that, it's going to throw an error. So it helps you also to define what you want to test, and also the unhappy path. Then you give the VI to test to someone else, as Danny said. Even I protect the VI, or I build it into a PPL, or I don't want the person to write the test to see the block diagram, because I found out that it's too easy to write the code to please the VI, write the test code. So if you don't see the code, you basically write the test based on the documentation. And at the same time, you test your documentation and the code. So I found it was really powerful.
Yes, that does sound like a really good idea. Although if you write the test first, there's no code in the block diagram for them to look at. But yes, if you're testing code that's already written, yes, I do agree that's a great idea.
There is opposite. If you write a test, you write a code. There is opposite way. If you write a test first, you read the code to please your test, not your needs.
Yes, I can see that problem. So yes, you should be, yeah, I don't know what the answer to that is other than write smart, intelligent tests.
Writing the documentation helps.
Yeah.
You write your test to please your requirements. So if you're pleasing your test, you are pleasing your requirements.
That is a great answer. All right, we have 1 minute. So any last minute questions? Comments? What's your favorite color? Color? Blue, obviously. I do have on a blue shirt, so. Yes, Danielle.
You mentioned a couple of times your blog. What's your blog website address?
It is automatedenver.com. Yeah, I guess I should put that up there. Other questions? All right, well, we got 30 seconds, so I think we're done. Any announcements or anything before we just break?
Yep, I have an announcement.